and a warm welcome to the AI with Arun show. In this video, we are going to deep dive into one of the most exciting technological initiatives happening right now. We often hear about Bengaluru being the Silicon Valley of India, home to every major tech company on the planet. But here is the story we don't hear as much. Outside of that glittering tech hub, a massive problem persists, which is access. Our video today is about a radical solution to that problem called KEO. KEO, knowledge driven, economical, open source. Now, KEO is not just a computer, it is Karnataka's blueprint for sustainable digital inclusion. The goal of KEO is revolutionary, to decouple intelligence from the cloud. We are here to show you exactly how this small device is built on open source technology to bring AI capability to even the most remote, unconnected communities. If you are looking for an affordable device that can run without the internet, the KEO Micro-PC is a sole viable option within the Keonix product lineup. So why is this KEO device necessary? Because we have a massive device gap. Now look at the statistics. Personal computer ownership in Karnataka households is stubbornly low, hovering at about 15%, 1.5. That's only slightly better than the national average of under 10%. This is not just about owning hardware, it's about a cognitive divide. With almost everyone has a smartphone, the smartphone is primarily a device of consumption, great for watching YouTube videos or scrolling social media. But try to code, try to write a long research paper, or run a complex simulation on a phone, it is structurally ill suited for these kinds of production and deep learning. So, what's the result? It's staggering. Over 60% of students struggle to effectively access online learning. This deficit is not abstract, it translates directly into higher dropout rates and a workforce that is ill prepared for the digital economy. Historically, governments have tried to fix this gap by simply distributing hardware, subsidized tablets, or cheap laptops. But these legacy models were based on a faulty assumption that everyone has access to ubiquitous, high bandwidth internet connectivity. The reality in rural Karnataka is different. Connectivity is often intermittent, it is slow, or too expensive for daily use. Now, think about a standard cloud native education platform. It needs a persistent connection to the server to run a quiz or watch a video. Well, that connection fails, and it often does. What happens to the device? It becomes a brick, and the learning process slams to a halt. The Q initiative is built to solve this fundamental flaw. It implements a fundamental architectural shift by ensuring that a student's ability to learn is not dependent on the whims of a telecom network. It puts the intelligence where it needs to be, on the device. Q's design isn't just about saving money, it's about national strategic ambition, technological sovereignty. Right now, the global computing world is dominated by two proprietary instruction set architectures, the ISAs, the x86 from the Intel AMD, and the ARM owned by SoftBank. Now, think of an ISA as a language a chip speaks. So, what is an ISA? As I told you, it stands for Instruction Set Architectures. Now, using these requires paying significant licensing fees and, more importantly, makes us subject to the geopolitical tension of the nations that control them. KEO breaks this dependency entirely by adopting something called RISC. So RISC-V is an open standard ISA provided under open source licenses, meaning there is zero fees and zero foreign control. This strategic pivot allows the state to transition from being a consumer of foreign IP to a cultivator of indigenous silicon capability. The company is partnering with Exaleap, a Bangalore based design firm actively nurturing a local ecosystem capable of designing complex microprocessors. Now, let's talk about the hardware itself. There is a crucial clarification that we need to make. The Q device is not a traditional laptop, it's a micro PC or a compute box. Imagine a sturdy compact unit like a large set box. This design choice is key to the economics. A laptop screen and battery are the two most expensive components. By eliminating the integrated screen, keyboard, and battery, the cost is drastically reduced. This allows the engineers to reallocate the budget towards the powerful components we need, like the specialized AI core and the necessary RAM. Crucially, the micro PC is far more robust and less prone to common educational failures like hinge breaks or cracked screens because it has no moving parts. This enables the bring your own screen model. We assume the school or the household already has a device. Let's say there's an old TV or a spare monitor, and KEO simply turns that screen into an intelligent, modern AI workstation. Inside that robust box lies the core engine, a quad-core V64-bit processor clocked at 1.8 gigahertz. Now, this processor wasn't bought off the shelf from a global giant. It was designed right in Bengaluru by Exaleap Semiconductor Private Limited. Exaleap is focused on leveraging the open standard of RISC-V to create custom systems. This is a huge step for the state cultivating intellectual property locally. Now for a dose of reality. While the design is indigenous to Karnataka, the actual fabrication, the manufacturing of the raw silicon wafers was conducted in Taiwan. This reminds us that while we are rapidly advancing, we still rely on established global foundries for manufacturing high-end logic chips. This configuration is optimized for efficiency. It runs a streamlined Ubuntu Linux OS, which, coupled with the reduced instruction set of RISC-V, allows the device to run cool and efficiently, perfectly balanced for a student workstation. Now let's talk about the offline AI, the Neural Processing Unit, the NPU. So this is the star of the show and the reason why Q is different. It's on-device AI core or the Neural Processing Unit NPU. So why do we need an NPU in the first place? So think of it this way. Standardized CPUs are like single lane roads, good for general traffic. AI models require massive parallel calculations, like multiplying giant tables of numbers, which we call matrix multiplication. Now, running this on a standard CPU would be painfully slow. The NPU is a specialized silicon accelerator. It's a dedicated 100-lane highway just for AI tasks. The KEO NPU delivers 4 to 5 TOPS. So TOPS stands for trillions of operations per second. Now, this is the necessary sweet spot to run powerful educational models efficiently without high cost or massive power draw. The mechanism is simple and profound. When the student asks a question, the NPU processes it entirely inside the KEO box using models stored locally. No data packet leaves the device. This guarantees two critical things: zero latency related to internet speed and absolute data privacy. If the NPU is the engine, the killer application is the software, which is BUDDH. So, what does BUDDH stand for? BUDDH, Bharat Unified Digital Development Helper. BUDDH. It's not a generalist like a Chat GPT or a GPT-4. It's a small language model, SLM, that has been trained on a highly curated specific data set. The Karnataka Department of State Education Research and Training syllabus. This domain specific training is its superpower. When a student asks about the Indian history, the AI does not give a general internet answer. It gives the answer that perfectly aligns with their textbook. This avoids irrelevant information or the hallucinations that general AI models sometimes produce. Both is engineered to be a patient on demand tutor 24 by 7. To run this powerful AI on low power hardware, engineers use techniques like quantization, which means compressing the model to take up less space, and on device RAG. So, RAG stands for Retrieval Augmented Generation, where the AI pulls facts directly from the syllabus files stored on the device. The currently both operates in English, but the crucial next step, the non negotiable step for success in rural areas, is integrating robust Kannada language support, which is the local language for Karnataka. Now let's look at the specs that make KEO affordable yet powerful. It comes equipped with 8 GB of LPDDR4 RAM. This is crucial because 8 GB is necessary to hold the entire operating system and the AI model simultaneously. Storage is constrained at 32 GB internal, but this is compensated for by modularity. The device supports expansion up to 1 TB via external drives. This modular approach keeps the base price low at 18,999 Indian rupees. So, for connectivity, the most critical feature for rural areas is the integrated 4G SIM card slot. In many villages, cellular coverage is pervasive, even when wired broadband is non existent. This eliminates the need for expensive dongles or tethering. Finally, the operating system is Ubuntu Linux. This choice eliminates significant licensing fees associated with Windows, saving cost, and is inherently more secure, reducing the maintenance burden on schools. Now, we need to address the confusion between the KEO and standard laptops sold by Kionix. So, Kionix sells premium third party laptops from companies like HP and Dell. So, look at the comparison. A standard commercial laptop like the Dell Vostro or the HP model costs about 57,000 Indian rupees and 70,000 plus rupees. They use proprietary x86 chips, and the AI features are entirely online and cloud dependent. The Q AI device, on the other hand, costs only 18,999 rupees, or just about 19,000 rupees. So almost a third of what the Dell or the HP model costs. It uses open source RISC-V chips, provides offline AI capability via the NPU, and integrates a 4G SIM. KEO is not trying to compete with its high-end mobile office machines. It's positioned as a disruptive inclusion device. It makes high-tech personalized education financially viable for government schemes costing less than a third of the proprietary alternatives. The impact of KEO goes far beyond the price tag. First, it addresses the knowledge divide. By providing a patient, knowledgeable AI tutor 24 by 7, KEO is making personalized top tier tutoring available to students who could never afford it before. This is a massive step for educational equity. Second, consider sustainability and e waste. The micro PC form factor is much more resilient. If a keyboard breaks on a KEO, you buy a new one for just rupees 300. If the keyboard breaks on a laptop, the whole unit often requires expensive, complex repair. Crucially, because KEO runs on external power, mains, UPS, or solar, it avoids the integrated death clock of internal batteries that often render laptops useless after just a few years. This means longer lifespans and less e-waste. This vision has already earned powerful industry validation. Corporate leaders like Chris Gopalakrishnan, who is the co-founder of Infosys, Kiran Majumdar Shah, the chairperson of Biocon, have endorsed the project by ordering 1,000 units for school distribution. Now, that is a powerful vote of confidence in the technology. In closing, KEO AI PC is more than hardware. It's a policy statement. It's an assertion that the global south must build its own digital future, free from dependency on external proprietary licensing and persistent internet connectivity. We are trading the mobility of a laptop for the sovereignty, affordability, and offline intelligence of a dedicated edge AI workstation. But the journey is just beginning, and there are challenges ahead. Adoption inertia, of course. The company must train teachers and students to shift comfortably from Windows to the Linux interface. Then there is peripheral burden. The bring your own screen model is cost effective. For the very poorest, lacking a monitor can be a barrier. Bundling low cost peripherals might be a necessary next step. Now, to talk about software maturation. The biggest technical hurdle in developing high quality, stable, offline, Kannada language models. This engineering effort is essential for KEO to truly serve rural classrooms. Because remember, it only supports English as of now. The ultimate success of KEO will be measured not in the lab, but by the robustness of its deployment in the real, dusty, heat stressed reality of rural classrooms. It's, of course, a bold blueprint for digital independence, and the journey has just about started. So, with that, we come to the end of the show. Please support our work by joining us as a member. And if you learned anything from this video, please like, share, and subscribe to the AI with Arun show. Thank you so much for watching, and we will be back soon.